Take a look at start chapter 2, section 2.1, and we're going to start by talking about the graphs of sine and cosine. Sine and there's 6 trig functions, and out of the 6 trig functions, sine and cosine are what are called continuous functions. If you think back from algebra, a continuous function in algebra is a function that you can put your pencil on the graph and you can trace the entire graph without removing the pencil from the paper. All right, that's a continuous graph. Sine and cosine are continuous. The other 4 trig functions, cosecant, secant, tangent, cotangent, they are discontinuous functions. All right, so that means when you trace them, you have to take your pencil off of the paper and then put it back on the paper to continue tracing the graph. As far as the lecture notes are concerned, in the lecture notes section, this is basically coming out of section 8.6. Okay, just for a reference. I'm not going through all of the slides on 8.6, but I'm just taking some slides like here and there. All right, so with that being said, we're going to talk about the graphs of sine and cosine. Many things in daily life repeat with a predictable pattern. Because sine and cosine repeat their values over and over in a regular pattern, they're examples of what are called periodic functions. Okay, so periodic functions, they're like cyclic in nature. They repeat over and over. For example, weather. Right? Weather is cyclic or periodic because it repeats over time. A periodic function is a function f such that f of x is equal to f of x plus n times p. We're going to talk about this specifically when we talk about the trig functions. For every real number x in the domain of f, every integer n, and some positive real number p, the smallest possible positive value of p is called the period of the function. All right, so we're going to talk about what the period is, and the period is the time to complete one cycle or revolution. Okay. So the period of a function is simply the time it takes to complete one cycle or one rotation. Before we actually talk about the functions themselves, we're going to talk about the period and the amplitude. Now, we talked about the period, and the period is just the amount of time it takes to make one complete cycle. There is a function for the period. The period is equal to 2 pi over b. Okay. In this particular section, we're going to deal with some basic model forms. Right. For example, y is equal to a times the sine of bx. Now, this is just a basic model form. In every trig function, it has to carry a value for a. If you don't see a value for a, it's understood to be 1. The argument of your trig function, and sometimes you're going to see this argument in a set of parentheses. Sometimes you won't see it in a set of parentheses. You have your variable x, and b is the coefficient of your variable x. So if you don't see a coefficient for x, it's understood to be 1. Now, here are some of the basic model forms. You may see y is equal to a times the sine of bx. Y is equal to cosine Let me just write it all out. A times cosine bx. You may see y is equal to a, or I'll just stick with sine and cosine since we're in this section. Okay, so if you're looking at these two model forms, the period, that's going to equal to 2 pi over b. Right, so to find the period, or the amount of times it takes to make one complete revolution, you're going to take 2 pi, which is given, and then you're going to divide it by the coefficient of your variable x. Okay. The amplitude that's going to equal to the absolute value of a. So what is the amplitude? Well, the amplitude is the difference between the maximum and the minimum values. It's basically the height of your trig function. And then it goes to say in the note, the graph of y is equal to a sine x, or y is equal to a sine cosine x, will have the same shape of y is equal to sine x, or y is equal to cosine x. All right, so the amplitude is going to be the absolute value of the coefficient of your trig function. All right, so if you don't see one, it's understood to be a. Now we're actually going to graph a basic sine and cosine curve, and we're going to point out this period and the amplitude. All right, so we're going to look at the traditional sketch of a sine or a cosine function. And it's just these 5 steps. Okay, so it says to graph a is equal to sine bx, or y is equal to a times cosine bx. First thing we have to do is find the period. Then we have to quarter the period, or we have to break the period up into 4 equal parts. Then we evaluate our trig function based on the numbers found in the previous step. We plot the points, and then we draw additional cycles as needed. So we're going to use these 5 steps, and we're going to graph sine x. All right. So the first thing we're going to do is we have to find the period. All right, there's a formula for the period, which is 2 pi divided by b. So if I look in my function, notice there is an understood a, which is 1. All right, so all trig functions must have a coefficient, and this thing has a coefficient of understood 1. And then b is the coefficient of your variable x. So my coefficient here for my variable x is an understood 1. So in this formula, I'm just going to substitute b for 1. So the period is 2 pi. Right. So this graph is going to make one complete cycle, or one complete rotation, right, every 2 pi radians, or 360 degrees. So that's the first step. The second step says quarter the period. All right. So we're going to take 2 pi, which is the period, and we're going to quarter it. We're going to cut it into fourths. So I'm going to take the period, which is 2 pi, and I want to multiply that by 0 over 4. I want to take 2 pi and multiply that by 1 over 4. I'm going to take 2 pi and I'm going to multiply that by 2 over 4. And 2 over 4 is a half, but I just want you to see how we're quartering the period. Next, I'm going to multiply 2 pi by 3 over 4. And then lastly, we're going to multiply 2 by 4 over 4, which is 1. So now I'm just going to simplify. So 2 pi times 0 is 0. 2 pi times a fourth, well, the 2 and the 4 are going to reduce to 1/2. So we have pi over 2. 2 pi times 2 over 4, well, 2 times 2 is 4. The 4s are going to cancel, and that just leaves pi. 2 pi times 3 over 4. 2 times 3 is 6. 6 over 4 reduces to 3 halves pi. And then 2 pi times 1 is 2 pi. Right, so I simply took the period, which was 2 pi, and we multiplied by 0 over 4, 1 over 4, 2 over 4, 3 over 4, and 4 over 4. So now once you quarter the period, the numbers that you actually get, they serve as the x-axis, or the x values. So on the third step, we're going to evaluate. So we're going to take those numbers that we just found in the previous step. We're going to make an X and a Y chart. Right? Because to graph anything, we're going to make an X and a Y chart. So my X values are the numbers we just previously found. 0, pi over 2, pi, 3 pi over 2, and 2 pi. All right. Okay, so I'm just going to shrink down on this just a little bit. All right, so we found the period. We quartered the period. These quartered values, they serve as the X values in our XY chart. So X is going to be the values that we just found. Y is going to be our function, which is sine X. Right. So Y is equal to the sine of X. So basically what we're going to do is we're going to complete ordered pairs. All right. So in my function, y is equal to sine of x, wherever I see an x, I'm going to substitute that with 0. So if we were to substitute 0 for x, what would be the sine of 0? 0, right? So that gives me my first ordered pair point, 0, 0. To find my next ordered pair point, I'm going to substitute x for pi over 2. So what is the sine for pi over 2? Okay, it should be 1, right? So let me just show you where I'm getting these values from. If I go back into the formula sheet section, I'm going to pull up the unit circle function values chart. And this is where I'm pulling those values from. So for example, right. So let's say we wanted to find the sine of 0. So I would just find 0 radians. I would locate the sine, and it would be 0. In order to evaluate the sine of pi over 2, I can find pi over 2, which is 90 degrees. The sine of pi over 2 is 1. I can find the sine of pi. So remember that pi is 180 degrees, so the sine of pi is 0. The sine of 3 pi over 2 should be 1. And then we complete 1 revolution, and the sine of 2 pi is 0. All right, so any questions about this X and Y chart? All right, so now if we lay this out in a coordinate system, I need to move that down. Okay, so on my x-axis, I'm actually going to list out these radian values. So this is 0. This is pi over 2. This is pi. 3 pi over 2 and 2 pi. So notice on my x-axis, I don't have 1, 2, 3, 4, right? I have the radian measures for x. Okay, so once we corded it up, those values actually lay out our x-axis. As far as my y-axis is concerned, I only have 3 numbers. Positive 1 for y, then 0, which is here, and then negative 1. So now I'm just going to plot the ordered pair of points. So my first ordered pair is 0, 0, so that's at the origin, which is here. My next ordered pair is pi over 2, 1. So I'm at my origin. I go over pi over 2 units to the right. I'm going to go up 1. The next point is pi, 0. Right, so I'm at the origin. My x coordinate is pi, so I go pi units to the right. My y coordinate is 0, so I'm not going to move up or down. I'm going to stay on the x-axis. My next ordered pair point is 3, 3 pi over 2, 1. And I'm sorry, that should be negative 1. Right. Just double check that. So the sine of 3 pi over 2, right, that should be negative 1. All right. So now I'm going to plot this point 3 pi over 2, negative 1. And then the last point is 2 pi, 0. And if I connect the points, all right, this should be the graph of y is equal to the sine of x. All right, so the period is the time it takes to complete 1 revolution. All right, so that period is 2 pi. The amplitude, if I go back to the definition, because I'm going to explain both ways. This says the amplitude of the periodic function is half the difference between the maximum and minimum values. Right? So if I were to look at my graph, and if I were to look at the maximum or the highest point on my graph, notice that this goes up to 1. Right? If I look to the smallest point on my graph, and if I go up to the x-axis, since I'm talking about distance, that actually has a distance of 1. So the distance from my bottom point to my top point is actually 2, right? Because I would go up 1, and then I will go up 2. But then you must cut the distance in half. Right? So 2 divided by 2 gives me 1. Or I can use the formula that says the amplitude is going to be the absolute value of A. So notice that in this particular case, A is understood to be 1. Right? So my amplitude is 1. So it's like you take the maximum distance from the very top and the very bottom, and then you cut it in half. Right? So I can get 1 that way, or I can use the fact that it's the absolute value of A. All right, so this is the sine graph. If I go up 1 second, there is like a little function capsule. So notice that this is only for 1 revolution. So we're only going from like 0 to 2 pi. Since this thing is periodic and it's cyclic, we can draw additional cycles as needed. Now here's just some background about the sine function. And the only thing that's really important to this class is the fact that the sine function is an odd function. So now once we get into module 3, it talks about odd and even. And in the notes, you don't see it anywhere in module 3. But you see it here. The sine function is an odd function. Okay. So remember that odd functions are symmetric with respect to both the x and the y-axis. The graph is continuous. That means you can put your pencil on the paper and trace the entire graph without removing the pencil from the paper. And then there's just some facts. The x-intercepts are in the form n times pi, where n is an integer. So what that means, if you take any integer, which is any positive or negative whole number, and if you multiply that by pi, those will give you the x-intercept points. Okay, those are the point where your graph touches the x-axis. Okay. Well, we don't find x-intercept points in this class. The period is 2 pi. Okay. All right, we're also, any questions about the sine curve? All right, we're also going to graph the cosine curve. All right, and we're going to do it much the same way. So we're going to graph y is equal to cosine x. So the same steps we're doing to graph these two basic curves, they're going to be the same steps we use to graph the problems in the homework. All right, so y is equal to cosine x. The first thing we want to do is find the period. So the period has a formula which is 2 pi over b. So remember that b is the coefficient of x. So the coefficient of x is an understood 1. So when I substitute in that understood 1, that gives us a period of 2 pi. All right. So the first step is always to find the period. The second thing we're going to do is quarter the period. Now, since the period is 2 pi and the period on the sine function was also 2 pi, I can use these same values, right? Because once we quarter 2 pi, we're going to get these exact same values. So once we quarter the period, we should have 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, we're going to see a problem in just a minute where the period is something other than 2 pi. All right, so we quarter the period. The next thing we're going to do is evaluate. All right, so I'm going to make the X and Y chart. So the X values are the quartered up parts of the period, right? So there's 0, pi over 2, pi, 3 pi over 2, and 2 pi. And this time y equals to cosine x. All right, so we're going to do the same thing. We're going to substitute x for 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So for this first ordered pair, if I were to substitute x for 0, the cosine of 0, and again, I'm taking these values from if I can find it. All right, so here again, I'm taking the values from, all right, the unit circle function of value. So the cosine of 0 is going to be 1. The cosine of pi over 2 is 0. The cosine of pi is -1. The cosine of 3 pi over 2 is 0. And then we make one complete revolution. The cosine of 2 pi is 0. It's 1. I'm sorry. That should be 1. Okay. So now we're going to graph. So the x-axis we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. If we look at our y coordinates, we have 1, 0, and -1. So that's 1, 0, and -1. And if we plot the points, the first order pair point is 0, 1, pi over 2, 0, pi, -1, 3 pi over 2, 0, and pi over 2, 1. And that's a graph of y is equal to cosine x. All right, so here again, the period is 2 pi, and the amplitude is 1. All right, so any questions about the basic sine and cosine curve? So now just some facts about the cosine curve. The cosine is an even function. So remember that sine is odd, the cosine is an even function, and just remember that even functions are symmetric with respect to the y-axis. So that means if you were to take the graph, fold it along the y-axis, it would overlap onto itself. Exactly. All right, now I'm just going to take a look at these on a calculator. And I'm going to graph sine x just to show this. So I'm going to go into, turn it on first of all. Whenever you graph any trig functions, you want to make sure that you are in radian mode. Now the calculator is not so much a important part in this one, but in the next one you can kind of go in, especially with the discontinuous functions. All right, so I'm in radian mode. I want to go back to y equals, and I'm just going to put in the sine of x and graph. Okay. So once I have it in radian mode, notice that my x-axis actually has these scales. It has 0, pi over 2, pi, 3 pi over 2, and 2 pi. Now, if you're seeing something other than what I'm seeing here, I can go into zoom, and if I scroll down to number 7, it says Z trig. If you weren't seeing it before, it all depends on, I was doing some graphing earlier. Instead of saying like 1, 2, 3, 4 all the way to 10, once you hit zoom trig or Z trig, it puts your graph having an x-axis in radian measures. So the graph on the calculator looks similar to your hand sketch. Okay. So now if I go back to zoom, and I think, is it 6? Okay. Okay. So notice now if you graphed it initially and it looks something like this, this is actually in a scale from -10 to +10 going by increments of 1. But if you hit zoom and trig, notice it gives you an x-axis in radians. So that's just a little trick. If you're trying to graph the function and calculate and kind of match the graph to a given answer choice, I would put my calculator first off in radian mode, and then I would use that zoom trig. Okay. All right, now let's take a look at some problems. And I don't know how this is going to quite look. All right, can everybody see that? Okay, so this is actually similar to the very first problem. And it says graph the function and state the amplitude, period, and the midline. State the maximum, minimum, and the corresponding x values on one period for x is greater than or equal to 0. All right, so we're going to follow those exact same steps we did before. We're going to sketch it out by hand, and then we're going to take a look at the graph, okay, how to actually put it on the computer. All right, so let's graph y is equal to 5 times the sine of x. So the first thing to do is to find the period. So the period has a formula. It's 2 pi over b. And if we take a look at our function, remember that b is the coefficient of x. So b is an understood 1. So therefore our period is 2 pi. All right, so now you got to be careful. If you look at this graph, it actually goes from 0 to 4 pi. So this graph actually makes 2 revolutions. So we just have to be mindful that when we're plotting our points, that we are within this first revolution. Okay. So we found the period. The second thing we're going to do is quarter the period. So since the period is 2 pi, I can use the quartered period values from the previous 2 examples. So we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. The third thing we're going to do is evaluate. All right, so we're going to make an X and a Y chart. All right, so I've listed out the quartered values as X. The Y values are going to equal to my function 5 times the sine of X. All right, so now we're just going to plug in the values. So in order to find 5 times the sine of 0, let me just write this out. The first thing I want to do is find the sine of 0. And if we take a look at that function values unit circle, the sine of 0 should be 0, right? So 5 times 0 is 0, and that's the first order pair point. So notice I must simplify my trig function first and then multiply by 5. So for the second order pair point, the sine of pi over 2, that should give me 1. Right? So the sine of pi over 2 is 1. And 1 times 5 is 5. So that's my second order pair point, pi over 2 comma 5. 5 times the sine of pi. Well, if I find the sine of pi, that's going to give me 0, right? And then 0 times 5 is 0. 5 times the sine of 3 pi over 2. The sine of 3 pi over 2, I believe that's going to give us negative 1. Negative 1 times 5 is negative 5. And then we're going to complete one cycle. So the sine of 2 pi is 0, and 0 times 5 is 0. All right, so it's similar to the first couple problems. So we're going to sketch it out. Okay, so on the x-axis we have 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then on y-axis we have positive 5, 0, and negative 5. So now we're going to plot the ordered pair points and connect for the graph. So our first ordered pair point is 0, 0. The second ordered pair point is pi over 2, 5. The next is pi, 0. 3 pi over 2, negative 5. And then one complete rotation at pi, 2 pi, 0. All right. So this is y is equal to 5 times the sine of x. So now let's answer the question. So what is the amplitude? Well, y is equal to 5 times the sine of x. The amplitude, that's equal to the absolute value of a. And just remember from our model form, a is the coefficient of your trig function. So the coefficient of our trig function is 5, and the absolute value of 5 is positive 5, so that's the amplitude. The period. So we actually had to find the period the first step once we perform the graph. So the period is 2 pi. Right, it makes one complete revolution in 2 pi radians. The midline. Okay. The midline is the graph that's in the middle of your graph. Is that in-between point. So if my bottom minimum is negative 5, the top is positive 5, the midline is actually the x-axis. They want you to write out an equation for the x-axis. So the equation for the x-axis is y equal to 0. So the midline is the line that cuts your trig function in half. So you must write that out as an equation, is y equal to 0. Next, we're asked for the minimum and the maximum. So now if you're looking at this graph, the maximum is going to be located here, right? The maximum is like at the top of the hill. The minimum is going to lie in the valley. So if I had to write out an ordered pair coordinates for the maximum, that's going to be the point pi over 2, 5. You must write out the maximum in an ordered pair format. So my maximum is pi over 2, 5. So that's the coordinates for this point that's on the top of the hill. And for my minimum point, that's going to be the point in the valley. So that's going to give me the coordinates 3 pi over 2, negative 5. So my minimum value is 3 pi over 2, negative 5. Any questions about the midline, the maximum, or the minimum? Okay, hopefully my problem has not changed. So now this is the way I attempted to graph it on the computer. So first off, notice that my hand sketch only goes from 0 to 2 pi. So I don't want to go over here and plot any points. I'm then going to take my minimum point, which is 3 pi over 2 comma negative 5. So I believe that's going to be here. 3 pi over 2 comma negative 5. And then I'm going to plot my maximum point. So if I go back to my graph, my maximum point was pi over 2 comma 5. And pi over 2 is about right here. Comma 5. And I believe this should be the graph. So if I kind of line that with my hand sketch, it looks like those are about the same. So now what I did was I plotted my minimum point first, then I plotted the positive point. All right, so the amplitude was 5. The period is 2 pi. The minimum is, well, the midline is y equal to 0. The minimum is 3 pi over 2 comma negative 5, and the maximum was pi over 2 comma 5. All right, so any questions about the first problem? So make a hand sketch first. Then once you actually plot it on the computer, be careful of your interval. Right, plot the maximum, plot the minimum, then the maximum. All right, and that should give you a graph. All right, let's take a look at least one more that deals with the graph. Okay, and this one is similar to your number 5. I will ask the same 5 questions, but this time the function is a little bit different. It says graph 3 times the cosine of 2x. All right, plot it, get an amplitude, period, midline, minimum, and maximum. All right, so we're going to follow those same steps. The first thing we're going to do is find the period. So the period is equal to 2 pi divided by b. But if I look at this problem, the coefficient of b is going to be 2. So the period is going to equal to pi, right? Because 2 pi over 2, the 2's are going to cancel, and that just leaves pi. So the second thing we're going to do is quarter the period. So now, since I'm not using 2 pi as my period, I'm just going to write it out. So remember, that's pi times 0 over 4, pi times 1 over 4, pi times 2 over 4, which is a half, pi times 3 over 4, and then pi times 4 over 4, which is 1. So we get 0, pi over 4, pi over 2, three pi over 4, and pi. All right, so those are our quarter values. All right, so now we're going to evaluate. So X and Y chart. So 0, pi over 4. So I have all my X values, and we're going to substitute those X values into our function, which is 3 times the cosine of 2X. So I'm going to kind of write these out. So for our first ordered pair, that's 3 times the cosine of 2 times 0. So 2 times 0 is 0, right? So that's 3 times the cosine of 0. And what is the cosine of 0? Right, well, if we look back at the chart, the cosine of 0 gives us 1. So our first ordered pair point is 0, 3. So notice you have to evaluate the cosine function first and then multiply. All right, so if we were to evaluate that second ordered pair point, 3 times the cosine of 2 times pi over 4. Now, if I reduce 2 pi over 4, we're going to get 3 times the cosine of pi over 2, right? Because that 2 and the 4 are going to reduce to a 2. What is the cosine of pi over 2? Well, if I look back at the function values chart, pi over 2 is 90 degrees. The cosine is 0. So this is 3 times 0, which is 0. So that next ordered pair point is pi over 4, 0. For the next ordered pair point, that's 3 times the cosine of 2 times pi over 2. So if we simplify 2 times pi over 2, the 2's cancel, and that's 3 times the cosine of pi. And the cosine of pi should be -1. All right, so pi, the cosine is -1. And -1 times 3 is -3. So now we're going to substitute in 3 pi over 4 for x. So this is 3 times the cosine of 2 times 3 pi over 4. Okay, 2 times 3 is 6. 6 divided by 4 is 3/2. And the cosine of 3/2 pi, that should give us 0. So that's 3 times 0, which is 0. And then we're going to substitute in pi. So this is 3 times the cosine of 2 times pi. That's 3 times the cosine of 2 pi. The cosine of 2 pi should be 1. So that gives us our last ordered pair point of 3, comma 3. Well, pi, comma 3. All right, now we're going to graph so on the x-axis we have 0, pi over 4, pi over 2, 3 pi over 4, and pi. If we look at our y values, the maximum is 3, the minimum is -3. And we're just going to plot the points. So we have 0, comma 3, which is here, pi over 4, comma 0, pi over 2, comma -3, 3 pi over 4, comma 0, and pi, comma 3. And that gives us something that looks like that. Okay. So now if we answer those same questions, the amplitude that's equal to 3. The period is equal to pi. The midline so here again, the midline is the line that cuts directly through the center. So that's the x-axis. So that's y equal to 0. The max. So this is one thing I noticed about the maximum point. They will usually give, so notice like there's 2 maxes. There's like one here and there's one over here. Normally they're going to give the maximum as that first maximum point, which should be 0, comma 3. So now technically if you put pi, comma 0, technically if you put pi, comma 3, they're both maximums. So I hadn't actually tried to put in the other maximum. But if you're looking at the viewing examples, they're using that first point as the maximum, or the first maximum that your graph encounters. So this is the max. The minimum is going to be in the valley, so that's going to be pi over 2 comma negative 3. And then if you were to graph, and I believe this was problem number, and one thing I'm noticing is that this graph does not actually match this problem. Let's see, this is number 5. Yeah, so this is actually number 5. What I have on the slide, notice that this scale is going by like pi, 2 pi. But in the homework, it should actually be right. Notice this is going from pi over 2 to pi. So here again, if we look at our graph, okay, notice our graph goes from 0 to pi. So I'm only going to stay within this 0 to pi range. I'm going to plot the minimum point first, which is pi over 2 comma negative 3. And then I'm going to plot the maximum point. Okay, and that looks like it gives me about the right shape. So just a key thing, notice when we sketch it out by hand, we're going from 0 to pi, but on this answer key, they're going from 0 to pi over 2. So just make sure that you're graphing within the right interval. All right, the amplitude is 3, the period is pi, the midline y equal to 0, the minimum was pi over 2 comma negative 3, and the maximum was 0 comma 3. All right, any questions about number 5? All right, now there's 2 more, the last 2, 8 and 9. All right, this is problem number 8. And it says state the amplitude, period, phase shift, and vertical shift of the function. Now, this is a different model form than what we've been using. This model form actually has what's called a phase shift and a vertical shift. So let me just write out the model form. So y is equal to a times the sine of bx plus c plus d. Now you're going to see all kind of model forms. Sometimes they may use different variables, but notice this is the same exact form as what we have. So the amplitude, that's going to equal to the absolute value of A. The period, that's still 2 pi over B, right? Whatever the coefficient of your variable is. The phase shift is negative C over B. So here's what a phase shift is. In algebra, when you got to the translation of graphs part, you can take a graph, you can like move it to the left, you can move it to the right. That's called a horizontal translation. And in Trig, it's called a phase shift. Right? It's just moving something left and right. A vertical shift, that's an up and a down movement of a graph. So the vertical shift is D. So what this means is if you want to find the left or right movement of your graph, you will simply take negative, You would then divide C by B. That'll give you your phase shift. If it's negative, that's a shift to the left. If it's positive, that's a shift to the right. And then the vertical shift is your up or down shift. So the vertical shift is simply that constant that's attached to your model form. So comparing that with our problem, what's going to be the amplitude? 2, right? What's going to be the period? Well, the period is 2 pi over b. If I look at my value for b, which is the coefficient of x, b is going to equal to 1/3, right? So now here's the period. 2 pi. I'm going to make the top a fraction. So I'm going to take 2 pi. I'm going to put that over 1. So that's still 2 pi. In the denominator, I'm going to write 1/3. Now you're going to see me do this a lot, like making a fraction over a fraction. There is an algebraic formula that we can use to, it's called simplify a complex fraction. So here's what a complex fraction is. You have a main fractional bar. In the numerator, you have a fraction, and in the denominator, you have a fraction. So now this is the form I'm going to use. It says that if you have A over B all over C over D, then you can multiply the very top and the very bottom, and you can multiply the bottom of the top and the top of the bottom. So that means when I'm simplifying this, I can multiply my very top and very bottom. So 2 pi times 3 is 6 pi, right? That goes in my numerator. And then I can multiply the bottom of the top and the top of the bottom. That gives me 1. So my period should be 6 pi. The whole equation was, so I simply took b, which is the coefficient of x. I put that in my denominator, 1/3. In the numerator, I changed 2 pi to 2 pi over 1. And then I use this little formula to simplify complex fractions. I multiply the very top and the very bottom. So 2 pi times 3 is 6 pi. Notice that goes in the numerator. And I can multiply the bottom of the top and the top of the bottom. That gives me 1. So the period is 6 pi. To find the phase shift, there is a formula to find the phase shift. And first off, this formula has a negative in it. Okay, so here's the phase shift. It's negative C over B. C is equal to, so notice my model form. C is going to be negative 7 pi over 4. So notice I got to keep any negative signs. And then there's a negative in my actual formula. So C is negative 7 pi over 4. B is 1/3, I believe. Right. B is positive 1/3. So when I simplify this, notice I have a negative that's a part of my phase shift formula. Then I'm going to take C, which is negative 7 pi over 4. I'm going to divide that by B, which is 1/3. So a negative times a negative is going to make my final number what? Positive. And then I can just use that formula. I can multiply the very top by the bottom. So 7 pi times 3, that's 21 pi, and that goes in the numerator. And then if I multiply the bottom of the top and the top of the bottom, 4 times 1 is 4. So our phase shift is 21 pi over 4. So that means that the graph was shifted 21 pi over 4 units to the right.
What made the 1/3 negative as well? Because I see how the phase shift is minus C over D, which is the whole fraction.
Right.
But
it's just the parentheses of the last one.
yeah, but does that make, because when I see minus C over D, one of them has to be negative. So both of them.
Well, now inside of this parenthesis,
Yeah.
that 1/3 is positive, but that 7 pi over 4 is negative. So I just have to make sure when there is a negative first off from the formula itself. And then when I put in my value for C, I must put in negative 7 pi over 4. And then 1/3. So when I simplify this, negative times a negative makes that final number positive.
I thought that was a negative inside the parentheses.
Yeah, that's okay. Yeah, that's a part of my, I'm sorry. Okay. Okay. All right, and then last, what is the vertical shift? Well, we take a look at our formula. That's right. The vertical shift is just going to be that constant on the end. So our vertical shift is 2 units up. Right. So the vertical shift is 2. All right. Any questions about that one? Number 8. For whatever reason, all of the model forms we've been using up to this point, they didn't include a phase shift or a vertical shift. Okay. All right, now for the last one, this is problem number 9. Okay. And I actually found the Ferris wheel diagram to kind of better explain this. It says a Ferris wheel is 20 meters in diameter. So remember that the diameter goes from one rim of the circle through the center to the other. So it's 20 meters high and is boarded from a platform that is 1 meter above the ground. So from here, all right. So this is the setup. So the Ferris wheel is 20 meters high, and then on this platform where you actually step to get into the Ferris wheel is 1 meter. It says the 6 o'clock position of the Ferris wheel is level with the loading platform, and it gives 1 full revolution in 10 minutes. So it's going to take this Ferris wheel 10 minutes to make 1 complete revolution. So that 1 complete revolution, that's also the period. The wheel completes 1 revolution in 10 minutes. The function h of t gives a person's height in meters above the ground t minutes after the wheel has begun to turn. First thing we have to do is find the amplitude. So they don't really give us a function, but remember from our definition of amplitude, it is the, I think I got it on here. It's half the difference between the maximum and the minimum values. So that means that altogether the Ferris wheel is 20 meters long. So what is the amplitude? Is it going to be 20 meters or is it going to be half of that? It's going to be half. So the amplitude is the diameter cut in half. So it's 20 meters divided by 2, so that's 10 meters. That is the amplitude. What's the period? Now remember, the period is the amount of time it makes one complete revolution. So the period is 10 minutes, right? They gave that to us in the problem. What's the midline? Well, the midline would be like right in the middle, but I got to account for what? The 1 meter here, right? So the midline, we're going to take the diameter, we're going to cut that in half, which will give us 10, right? But there's a 1 meter rise for the platform that you have to account for. So the midline is going to be the diameter divided by 2 plus the platform height. So that's going to equal to 20 divided by 2 plus 1, which should give us 11, right, meters. Now the last one says, how high off the ground is a person after 5 minutes? Okay, so think about this now. It takes 10 minutes for this Ferris wheel to go from here all the way around here, right? It's 10 minutes. So in 5 minutes, it would be where? It would actually be at the top, right? So what's that distance from the top to the ground? Should be 21 meters. So here again, it takes 20 minutes for this to go around one full revolution. That means in 10 minutes, this car is going to go from here all the way up to the top. So in order to find that height, it would be the height of the Ferris wheel plus the 1 meter for the platform. So that's going to be 21 meters.